Hello and welcome to the video where I will be going through my project of machine learning. I am from Depstar, Department Computer Engineering. My name is Luhar Ayush, 21DC052, and my project is Pixels to Text, a comparative evaluation of convolutional neural network and recurrent neural network models for image caption. So let's move on to what is image. So what is image captioning? Image captioning is a thing that we do in our daily lives without even realizing it, like we are looking at a scene and our mind is automatically translating the scene into a textual format for us to describe to others if we want. So how does a computer look at an image? That's the tricky part. Computer is bounded by its binary input, so we cannot provide image directly to the computer. So the backend is like the backend workflow would be like that image is a pixelated form of many pixels combined together. So the pixels will be then converted into binary input. It will be flattened. It will be converted into a sort of array, and then it will be provided to the computer. When uh, then a computer can understand what an image look like. So how does it classify among different images? That's where the CNN and RNN, the convolutional neural network, comes in. It helps the computer to identify that this feature is of this image because it has already been trained on different data set. Before moving to the objective, let me tell you about how the project works. So we are combining CNN and RNN both models to generate captions. CNN will extract the features and RNN will combine the features and form a sentence. Thus, a caption can be formed. So there are many models of CNN as well as RNN in the market right now. Like for CNN, we have VGG 16, 19, and ResNet 50. As well as for RNN, we have LSTM, GRU, DNC. But among them, which to choose? So the main objective of our study would be providing a empirical comparison between all the models. So the choosing of a model for the specific purpose can be made easier.
Hello, my ID number is 21DC042 and I'm Josh Karanga. So now you may ask, what are the methods used that we have used for our project or research to maximize or to get the best result out of it? So what we did was to combine a CNN, that is a convolution neural network model, with the RNN, that is recurrent neural network models, to get the best result out of it. So we did a permutation and combination of every model that we have used. For CNN models, we have used VGG16, VGG19, and ResNet 50. And for recurrent neural network, we have used LSTM. So as you can see over here, we have used VGG16 plus LSTM model, VGG19 plus LSTM, and ResNet plus LSTM. So the data flow somewhat goes like the CNN model is used for the feature extraction for the image, and that feature that gives the end result of a feature vector in the single dimension, and that is fed to the RNN model. The RNN model then creates a captions for the image. Now to verify those that the captions generated by the model uh, and the if it's correct or not, we use a Flickr 8K dataset, which has an inbuilt annotated captions with the images itself. What were the results in the discussion? So basically, this is the evaluation metrics that we have used for the LSTM. These are the blue score, Rogue, and the Meteor score. Uh, this actually gives, we can create. This actually gives us the result of if the caption generated and the actual caption is correct or not, if it's matching or not. So that's it from my side. Now Christian will explain the rest of the slide.
Hello, my ID number is 21 TC067. I'm going to talking about applications and conclusion for the image captioning. So first, let's talk about the applications of it. So it plays a major role in social media and it was such a giant platform nowadays. Uh, For example, if the user uploads an image on the Twitter, he or she can manually caption that image according to their needs. But if they are failed to do so, then Twitter has an algorithm to actually auto generate the caption for that for better user experience or better recommendations to other users. Specifically, if we talk about the use case of it, then OLX, we can take example of if the new user try to sell something on this platform, but he or she is unable to give it a proper caption. Then if OLX has a better model to capture that image, then it can generate a valid title, a proper title according to their product. And for that, it can reach to more relevant users, more relevant audience. Uh, it has also affected such uh, such fields like robotics, agriculture, and education. Now, moving on to the conclusion, we have actually worked with four models, which few of them are convolutional neural network models. One of them is recurrent neural network. So we have worked with VGG16, VGG19, and ResNet 50, and we have also worked with LSTM. Uh, Among this, if we fuse up the ResNet 50 and LSTM, uh, then this is the base potential that we can get in terms of the scores. So we have considered some type of scores like blue score, rogue score, and BTR score. So here I have provided the ResNet 50 scores for it. So this is that we choose these two models for and efficient. And thank you.